So we have a panel. If the esteemed panelists who see their name here can join me, would much appreciated.
Happy to be here.
Yeah. Yes, thank you. Thanks. Hello. So I know that I asked you to send me the 3 bullet points, but because not everybody sent it, I'm gonna ask you to introduce yourself.
No problem.
Yeah, sure.
Hello. Excellent. Is Dr. Sanjay Basu here? No? All right. Well, thank you very much for joining us. I know it's one of the last panels of the day, so everybody's a bit tired. We're going to bring back the energy, hopefully, and keep this moving. Philip Farah, Vice President of Strategic Partnerships and Sales at IonQ. Very happy to be here with you. Thank you, A&M. Thank you, Olga. And thank you to all our panelists. Let's start with a brief introduction, and if I can ask each one of you to go in the order that you are seated on the table. Brief introduction, who you are, title, what company or institution do you work for, and then we'll go into the questions at hand.
Great.
Thank you.
Thank you. I go by Pops, which is easier to remember than that long name there. I'm with NY Creates, which is an R&D organization, nonprofit, 501c3, headquartered in Albany, New York. We are blessed to have an amazing team of industry, hardened veterans doing technology development, using 300 millimeter wafer scale processing. We're the only people in the world, in the US, and one other organization in the world that has a 300 millimeter wafer fab that is not behind corporate walls. So again, I like to say that I spend my dreams and my nightmares on quantum. We like to use the 300 millimeter wafer fab to develop superconducting qubits, to build SNSPDs and photon number resolving detectors and various other structures. I should also take the minute to thank the organizers, Olga and the rest of you here for giving me this chance to share my passion with you all. My connection with Texas goes a long way, actually. I was with TI for about a decade, and then when we left Dallas to go to New York, our neighbors told our 2 young daughters, "Don't let those damn Yankees tell you different, you're a Texan." And so one of them actually came here, found her way back home, so to speak, and is starting her PhD here at Texas A&M. So it's great to be here. Thank you.
Thank you, Pops.
Yeah, so hi everybody. Thank you for the opportunity to be here. It's quite an honor. My name's Salton. I'm a research scientist at Amazon, small company, you might have heard of it. We have quite a few different initiatives at Amazon in quantum computing. And actually, it's a large enough company that you might have thought the reason that we got into it was because we routinely solve very large, difficult problems, even just internally for our own operations every day. But actually, the reason that Amazon got into quantum computing is because they were hearing from customers about 6 years ago, or repeatedly for many years before that they were looking to us for guidance in how to navigate this emerging technology and how to get started. And so because of that, we got our own effort together in quantum computing, and right now it's a very vibrant effort. There's 3 main pillars. There's a cloud service, part of Amazon Web Services, that's just another service, so to speak, with quotes around this. It's very much like all of the other AWS services that you might be familiar with, but it's a way to access quantum computers in the cloud. It comes with an SDK, it comes with, everything's open source. There are very powerful simulators. It's managed in such a way that you don't have to worry about it. And it's there so that you can build, design, test, and run, and actually access hardware, real quantum devices through the cloud right now. As of today, you can access devices from IonQ, Rigetti, IQM, and QEra, and you can imagine this list is going to change and does change over time as devices become more and more come online. We also have our own quantum computing effort. It's based on campus at Caltech in Pasadena, California. It's integrated with the university. We're building our own hardware, and we recently announced our own chip. It's called Ocelot, based on the cat qubit architecture. It's pretty cool. And then we have a way for our customers to engage with us in quantum technologies. We have something called the Amazon Quantum Solutions Lab, which is an external-facing research group with a number of scientists and experts in quantum computing. And the goal there is for customers to come to us, and we work with them to figure out how we would actually use this new technology to solve problems that people actually care about solving, and to do the cutting-edge research for that purpose. So great to be here.
Thank you much, Dr. Salton.
Oh, hi, my name is Xin Zhan, and I'm from Hewlett-Packard Enterprise, from the quantum team, and I'm representing Hewlett-Packard Enterprise to attend this Texas First Quantum Summit. It's an honor to be here, and the reason why we are here is very clear. As HPE headquarters is located in Houston, we're definitely very proud to be here, and we have been serving the industry with our supercomputers for many, many years, as we have a lot of clients in the oil and gas industry, as well as NASA and a lot of national labs. It's really great to see some of the people here that are clients or working with the clients as partners with us. And in the Hewlett-Packard Enterprise, our quantum team actually has a relatively shorter history, about 2.5 years by now. So our team is a mixture of HPC engineers from HPC BU, as well as the quantum scientists that's with diverse background in the quantum chemistry and also quantum algorithm, and some of the hardware experts. So our current efforts was, and my personal background was more from exascale computing, so and with the HPC background. So our mission in the HPE quantum computing efforts is building a utility scale quantum computer, and we have been leading industry collaboration with many partners, including Synopsys, 1QBit, which is a superconducting qubit manufacturer focused qubit manufacturer company, and also other partners, including Quantum Machines, that are focusing on providing the low latency QEC network, and also some of the control systems, and as well as the University of Wisconsin-Madison is also part of our consortium, and we have just finished DARPA Phase A QBI project in the September. So we have quite some experience in this area already with a lot of consortium members that are working with us, and our goal is to really realize the utility scale computers, supercomputers, and our vision is really doing the HPC and quantum computing integration to build a quantum supercomputer that can scale up from today's 100 qubits to the future 1 million qubits level to realize the utilities, some of the utility applications in this area. Especially HPE has a long history as a system integrator. So we have a very mature system HPC infrastructure that are ready to incorporate a different modality of the QPUs into our HPC infrastructure as an accelerator, as what we are doing today with different modality GPUs and different architectures, so from different vendors and different partners. So, and we have been, in the last 2.5 years, we have been demonstrated a couple of very solid multi-nodes, multi-CPU and multi-GPU, large-scale applications that ranging, starting from linear solvers, that's a lot of our clients are interested in doing the CFD, and also in doing a lot of real-world utility, real-world applications. So we are using the quantum algorithm, HHL algorithm, and compare with traditional classical solvers provided like BLAS and LAPACK, and trying to benchmark the accuracy between them. And we are scaled all the way from a very small matrix to a very large matrix that runs on 512 AMD CPUs. And the second application we demonstrated in some of the supercomputing and international supercomputing events are getting into some of the QAOA for NP hard problems like max cut problems. And we are working with some of the software partners and scale the applications up to more than 1,000 CPUs. And the third one we actively working on and actually already demonstrated together with NVIDIA in the latest GTC was the transverse icing simulation that's getting into more advanced quantum condensed matter physics, doing a 2D transverse icing model. That simulation runs up to more than 1,000 A100 GPUs and up to 40 qubits scale. And also we are actively working on the partitioning the quantum circuits, which is adaptive circuit knitting algorithm. So we imagine that the QPU size will always be limited. To realize the utility scale quantum application in the future, we need the distributed quantum computing. So we are actively working on doing the circuit knitting algorithm and trying to cut large circuits and partition them into small sub-circuit and distribute all those sub-circuits onto different QPUs so we can realize the real scale up in the future. And we have a lot of demonstration in the GTC and also keep tuned in the SC this year as well. Those are the general applications we have been exploring, and we also have very mature infrastructure experimentation setup, both through the cloud to connect to some of the QPU backends, and also we are talking with a couple of hardware partners within our supercomputer centers in US and as well as Europe, and trying to do a real low latency on-premise that's trying to put the QPUs in the same data in the same room as the data center and connect it to our supercomputers through a low latency network. So those are some of the research we have been experimenting, and we also have a lot of ready to apply cases and also the infrastructures.
Thank you, Xin.
How you doing? My name's Bill Gonzalez. So I come from a probably unique area, compared to the people that are up on this stage. So we're a small defense contractor out of San Antonio, Texas. My degrees are out of the University of Texas at San Antonio. Primarily, we do software work for the government, for agencies like the NGA, the DoD, the Air Force, organizations like that. We primarily concentrate on the software side, but a few of us have been carved out. It's actually just 4 of us who are working on quantum efforts, mainly on the software side, mainly in QML. So as the previous speaker discussed, we're actually also working on quantum convolutional neural networks, dealing with drone detection, simple classification, nothing too practical yet, just basically getting our feet wet. Because we work on the software side, we try to look at the different platforms that are out there, Classique, Qiskit, things by Google, Cirque. Essentially what we're trying to do is trying to take what is being done in the universities and trying to apply it, or at least put it into a practical form where we can test things out. We do use simulators. We do also use tools like Quantum Rings out of Colorado, which is basically a simulation system that uses tensor networks to try to see if we can run some of these circuits on larger systems. Primarily what we're working on now, and ideally because we didn't have a partner to get with here in Texas, we're working with some folks out of NCSA, out of the University of Illinois, on a DARPA RFI related to the creation of abstraction machines and the realization of a quantum virtual machine, essentially taking a top-down approach instead of a bottom-up approach in regards to trying to design software that will allow us to basically utilize current problems and map them onto a quantum virtual machine. In other words, trying to get away from the circuit design, although we know that's important. Because we've done some experimentation, we also realize that a lot of people are leaning towards quantum-inspired now, quantum reservoir computing, looking at those things. And we're trying to team up right now with some of the primes that we've worked with in the past, Accenture, Deloitte, SAIC, et cetera, who we primarily work with, and basically act as an arm for them. The people that we have within our organization, we're also working on the workforce development side. So we have people who work in the software side who are helping us design virtual machines to run quantum algorithms on. So it's essentially taking things that we already know how to do, like Kubernetes, Dockers, et cetera, packaging these things up so that we don't have our quantum researchers having to redesign or change whenever a new Qiskit version comes out or a new Circ version comes out. We're trying to componentize and virtualize all these particular packages, make it easy for our developers to actually do work. We also have people who are working on PQC. Essentially what they're doing is not only studying how to be crypto agile, but also just understanding what it is or what it's going to take to create connections. For example, OpenSSH to connect to GitHub or to connect to other entities or organizations that are already using PQC. And primarily what we're hoping to do is just advance the industry. And so that's why we're involved in it, and that's why we're here. Thank you.
Thank you very much. I mean, we've heard on this, sorry, did I miss someone?
Just me, never mind.
You know what?
Hi, my name is John Randall. I'm CEO of Zyvex Labs, and I'm going to talk about really serious stuff, but to lead into that, I'm going to tell my favorite quantum joke. And those of you that know the punchline, don't yell it out. I want to have the punchline. What's the difference between a quantum theory conference and a fashion show? The difference is at the fashion show, the models actually work. With that said, I want to explain that I've been since grad school in the late 70s involved with bleeding edge lithography. I've done E-beam lithography, I've done X-ray lithography, I've done ion beam lithography, I've done state-of-the-art semiconductor photolithography. My little bitty company right now has the highest resolution and highest precision and no design rules lithography tool on the planet. It's used in research for doing primarily donor spin qubits. Michelle Simmons has 4 of our tools. Sandia National Laboratories has 4 of our tools. We have a little STM controller that fixes all the problems that for those of you that are familiar with STMs, they're wonderful surface science tools. For a lithography tool, they seriously suck. They crash their tips all the time. You really can't, because of creep and hysteresis, put the tip where you want it to be at any particular point in time. Yet, back in the mid-90s, Joe Lighting and Fade Navoris showed that even with all these limitations, at least you could do basic stuff by taking a hydrogen passivated silicon 100 2x1 surface, run an STM tip at a little higher voltage and current that you'd normally use for imaging, and you can remove a sub-nanometer line of hydrogen atoms. We've fixed the tip crashing, we fixed the creep and hysteresis. It's the most high precision tool in the world. Now, but it's only, at this point in time, a research tool. Manufacturing, and there's not an industry that needs more precision than quantum. Every single, some more than others, but every single quantum computing technology would do better if they had better manufacturing precision. Human technological progress has been held up by manufacturing precision more than anything else. Let me give you 4 quick examples. The wheel, steam engines, ball bearings, computing machines. Between the time that these were originally prototyped and realized in a prototype and when they're actually manufactured and make a societal and economic impact is usually 1,000 years or more. It got down to the computing machines about 150 years between the Babbage difference engine and, let's say, the Apple II. Quantum is attempting to be done with current manufacturing tools that do not have enough precision to take it to the level it needs to be. And that's what my main point is. We're a little tiny company, but we're trying to commercialize our ability to, a single tip STM tool is not going to get there. It's way too slow. It's using research only. We want to make nano imprint masks. Here in Texas, what was Molecular Imprints is now Canon Nanotechnologies, is now competing with ASML, and they have a higher resolution, potentially, certainly much, much better precision, much less design, much more design freedom, but they're limited by their 1x mask, and we can go beyond what E-beam can do at 15 nanometers. They've sort of run into the ground and have them compete with ASML, which their high-NA tools now doing 8 nanometers. We could make Texas the center of the universe for quantum manufacturing technology.
Thank you very much, and my apologies for missing you. I couldn't see you, so I moved now so that I can see everyone.
Apology accepted.
Well, on this table, we have a very interesting and diverse cross-representation. We have manufacturers, such as John and Pops. We have industry players, like large companies, HPE with Xin, and AWS with Grant. And then we have a small defense contractor working on software build. And so my question to you, one of the objectives of this seminar is to understand what can the state of Texas do to help you either bring your business to Texas, expand your business in Texas, taking advantage of the specifics that where Texas has a competitive advantage, and aligning this with the areas. I think, John, you started answering this question, but perhaps if we can go back from here, Pop, starting with you, and share with us what would make sense, what can the state do in order to help you expand your business in Texas?
Yeah, so I mean, one of the reasons why I'm here is because Texas A&M and NY Creates signed an MOU, an agreement some months ago, where we wanted to deepen our collaboration between our two institutions, right? And so I don't know the specific details, but I've heard that there is going to be a 50,000 square foot clean room that is going to be coming up here on this campus, right? And so given that we have almost 3 decades of experience on standing up a public-private partnership entity that has been the sort of rising tide that lifts all boats, we are looking forward to partner with Texas A&M in order to make this place a success. And, you know, I mean, yes, we want, each and every state wants to succeed, but I believe that we succeed through collaboration, we succeed together. So there are definitely strengths in Texas. The innovative spirit, the $1 billion of money that is coming around that the representative and the senators were talking about earlier. And so those are opportunities that I think we can leverage in order to make sure that we advance the state of the art. I do believe that there are ways in which semiconductor technology can be applied advantageously to quantum computing. Half my nightmares are occupied with that question. And I think we would like to be able to work with Texas A&M, and indeed all the Texas universities, to be able to say, if you've got a quantum circuit that you want to get built, and you would like to work with an entity that is not behind a corporate wall, how come, why not we work together to say, reduce your circuit idea to practice using state-of-the-art tools. Your graduate students don't need to worry about that vacuum pump going down or that tool going down, because at NY Creates, we have manufacturing discipline and research flexibility, right? And so we embody the meeting point between those two creative tensions, if you will. And so going back to the question that was asked as to what Texas can do, I think Texas should continue doing everything that we heard today. I would encourage the idea that we partner across the country, because in unity, strength lies in unity. So
maybe I want to follow up a little bit so that we are specific in terms of, so what I heard you say is, look, if there were contracts coming through perhaps universities that the state is financing, we would love to engage. Would that create an impetus for you to create a presence in Texas? Would that give you the opportunity to create, and then you spoke about the clean room, 50,000 square feet clean room. Like, having contracts, having access to the clean room, is that something that would give you an impetus to create presence in Texas and build an office in Texas, hypothetically speaking?
I don't think I'm paid. There are enough zeros in my salary to answer the question, but I believe that that is an opportunity that I would like to advance to my management and say, how can we work together with people? Because just as it is useful, even in this day and age, to be in the same room with somebody else, the collaborations are strengthened by being in the same place. So, the partnership and fabrication that we want to do, I'm sure will be strengthened by having a presence here. At NY Creates, for instance, the RPI has an office at our facility. Brookhaven National Lab would like to have an office at our facility. They're working towards that. PsiQuantum has got people at our facility. So there is advantage in co-location, and so I don't see why we shouldn't be able to work together in that respect. In order to help you get your clean room up the ground faster based on our learning.
Thank you. Thank you very much. Grant?
Yeah, it's an interesting question for me, because I'm from Amazon Web Services, which is, it's a big chunk of the internet. And so it's already sort of de-local and everywhere, and we have there's a big presence in Texas. And on the quantum front, I'll say that this service, Amazon Bracket, it's generally available to anybody. You just need an internet connection, or in some cases not, because there's an open source library, and simulators and everything can run locally. So it's ready and sort of poised to help a large number of people get started in quantum computing, I'd say. So I think the different question for me is not how we can expand that footprint from the Amazon side, but how we can sort of expand our engagement with folks within Texas. And in thinking of that, I think there are, I'd say maybe two ways, both of which we've heard a fair bit about at this event so far. One of them is in training and enablement and bringing more people to the table and filling this room and getting a bigger venue and stuff in subsequent years. There's a lot of value in having more smart people thinking about hard problems, right? The kind of progress that we see in bringing quantum computers to fruition, I think is bimodal. There's one sense in which it's just a slow, hard, steady slog of progress beating down the errors in your hardware day after day. And you need a lot of people. The more people you have doing that and finding ways to do it, the faster it'll be, just because that's sort of extrinsic. The other way is just in these brilliant flashes that you have from smart people talking to other smart people and thinking, aha, here's a clever way to solve a problem. And I think by having more folks, smart young people, like increasing the training coming from higher education and beyond, getting more people from industry thinking about the kinds of problems that we want to solve, that'll help on the algorithm and solution design. The other point of this is that, we heard also yesterday that there's, it's good to have funding coming in for quantum computing and quantum computing research, and this is why this new initiative is really great that it's launched now. We heard yesterday, I think, at the panel that there's going to be some onus on us to demonstrate the value of this money back to the people who have created it, the taxpayers and the community, and so we will need to then show some results from this work, and I think one way to do this is to have more of those brilliant flashes and show that actually, okay, it's nice to have jobs created from manufacturing and new plants, and obviously there's a lot of value created that way, but there's also value created in coming up with new ways of solving problems that people hadn't heard about. Even if they're not going to run yet and we need hardware that is a little ways away, people will know that, aha, there are results that are happening and the timeline is getting closer and the gap is coming down. And so a way to do this is again through funding, providing access to institutions and small businesses and companies to work with other groups like those like ours at Amazon, for example, who work with external partners to figure out how to solve problems that people actually care about. And I personally, in doing this for 6 years now or something, have noticed that there's a lot of value to be found, but also it requires there's a bit of a curve, both in learning, but also financially. There's a bit of a hump for a smaller company to get started in this technology, even if they are excited to do so. So providing access to funding for defense contractors, and I guess for university labs who are primarily only thinking about more abstract problems, but giving them an incentive to think about down-to-earth, real-world use cases is another example.
Thank you.
Yep.
Xin?
Yeah, so for HPE point of view, we're naturally geographically located in Houston. So Texas is definitely the place that we always want to participate in all kinds of events. And in the past, we are actually very actively engaging in all kinds of HPC related events within Texas. We have the program doing the hackathons with a lot of universities and academia institutes and maybe some of the other clients that get access to a lot of research students. And we also have the programs in the HPC world in the past that are focusing on like educating the students and also getting the students and researchers access to the infrastructures we have, the test bed, because we have the Cray EX system nowadays that's really popular, and we can get access for students, researchers to use our supercomputers to get a feeling of the latest and the greatest network, storage, interconnects, and all kinds of simulators, GPU, CPUs integrated all together to have fun. That's definitely one part of the continuous efforts we want to push into the quantum, as the quantum efforts within a lot of institutes are getting more and more, a lot of initiatives, as we hear in yesterday's presentation, a lot of local universities and institutes. We want to push that efforts and spread those impacts into the institutes and also get access to the latest research. So from like our company point of view, because we are a system integrator, so we want to follow exactly we want to have a mutual understanding with the academia as well in terms of the applications. We are aiming to build those supercomputer, quantum supercomputer that's utilizing the HPC and quantum computer integration. But what are we building that for is something we really want to get some help and keep following what the academia's frontier research is telling us. So on one side, we know that nowadays we are very mature in terms of remote execution. Like even with AWS, we have using Classic that they support. We have multiple applications like HHL is actually through Classic software, and then they are kind of using the AWS backend. That's very mature. But on the other side, we keep hearing from the clients that they want tighter integration, which means they want ultra low latency interconnects between your QPU, your dilution refrigerator, and your HPC racks. But what are the applications are we aiming for when we are talking about those ultra low latency tight interconnects and tight integration? Those are the questions we really want to get more clear answers by following what academia, especially the frontier research institutes, telling us. And also, currently we are more focusing on the NISC at this stage, but we are also working with a lot of software partners, like OneQubit is definitely one of our software partners that are in our alliance for DARPA, QBI Phase A. They are very specialized in doing the FTQC decoder, assembler, and maybe one of the industry leaders on that front. We are actively looking into the FTQC, and we're also working with quantum machines. They are providing ultra-low latency QEC network within the dilution refrigerators. So we want to know, we're building all this, but what are the applications that we're built for? So those are the questions we want to keep following what the academia researchers telling us. And on the other side is on the hardware side. So we now have access to a lot of hardware access of different modality QPU. We already partner with IQM and one of the application QAOA. We can not only run on the simulator, AMD CPUs, thousands of AMD CPUs, but we can also run the same applications on the IQM 20-qubit superconducting real hardware, quantum hardware device. So we are also actively talking with Quantinuum, IQM, IonQ, and also QEra. We want to test on different modality of the QPUs, trapped ions, and also neutral atoms. So, and also we know that some of them are working actively with the academia to build research quantum computers. We also want to follow those hardware advances we want to know whether the applications, how diverse the same applications can run on different kind of a modality, QPUs, and get access to some of the frontier research quantum computers that are developing more at the research phase. We hope that we can leverage these efforts through this kind of a summit, can get access to more collaborations with the research institutes, so we can test more doing more algorithm testings on some of the frontier research quantum computers. So those are the kind of goals we want to broadcast and really spread ourselves into this collaborative conferences and summit to get answers and at the same time seeking for collaborations.
Yeah, sounds like collaboration to help guide you in your investments is a very important point.
Yes, yes, yeah.
Thank you very much. Bill?
Yeah, I'll mention two things, again, coming from the small business world is, you see a lot of money sometimes come into states. Legislators were here talking about how money is going to come down. My concern is whether any of that trickles down to the small businesses that actually do employ a lot of people within the state. That's always hard. The money tends to go to, of course, the large organizations, and I can understand that. But I think, like we do in the defense or the federal world, is there's a procurement legislation that goes into each of these packages that says, okay, a certain percentage of that contract has to go to a small business, minority-owned or woman-owned. So I think that's important. I want to make sure that we don't get left behind whenever this industry does start pushing forward as it is. Secondly is also workforce development. So some of the people that we do employ within our organization do come from underprivileged areas. And so sometimes we struggle with getting people that are actually trained on the quantum side. A few of the people that we employed have gone to, for example, Qubit by Qubit has the coding school that's taught out of Stanford, so a few of them have gone through that. Q World is another organization that's provided some of the training. This is low-income training or almost free. I myself have gone through the MIT X-Pro schools as well. But I think that there needs to be more opportunity for some people who may not have that ability to take advantage of what's going to happen in this industry. So those are the two pieces that I think deal with procurement or legislation. In other words, making sure that we have an opportunity. And then lastly is access. I've heard a lot of people here, as I've talked to them during the poster presentation. A lot of us are basically bottlenecked by pre-processing on classical, pushing things up to quantum cloud, and then post-processing. If there was a way to move into an area where we could have HPC right next to quantum so that we wouldn't have to deal with some of those inefficiencies, that might be some way for us to solve some of the problems that we have. In fact, the question you had is where are all these issues, and that is the fact that we have to shoot up our loads to quantum computers that are held in the cloud. And so that basically means that some of our pre and post processing is the slow points. But we know those can be solved, right? With HPC, any pre-processing of imagery or any post-processing of imagery can be handled fairly quickly on an HPC system. Now, having those systems in place, I know Oak Ridge has some efforts, Argonne Lab has some efforts, but the idea there is to make sure that academia and businesses such as ourselves have access to that. So I've talked to a few people. I get to use some of the IBM computers that are available, but if I have to wait in a queue, some of my work is stymied. If I have to pay, again, that's a hard thing for a company such as ourselves to do. We're all more than willing to do the work and do the research and put our minds to it, but we want to make sure that we have those resources available so that we can freely do the work that we need to and then advance in that regard. Thank you.
It's interesting that you mentioned this point. One of the emerging models in many places around the world is where the government is investing in bringing infrastructure is to dedicate part of this infrastructure at no cost to academia, small businesses, startups, and then the rest is paid for by enterprises and industry players, larger industry players, so that the government can recoup part of their investment. But thanks for sharing those ideas with us. John?
Yeah, I want to double down on what Zen suggested about collaboration. if we're going to create a vibrant and not nation, but world-leading quantum technology community in Texas, it's going to take a lot of collaboration. Zybex Labs is a nano company. When I say nano, I mean very small number of people. We are forced to do collaboration because we don't have the resources within. We've gotten fantastic collaborations from UT Dallas, especially Reza Mohimani, that Mike Kay mentioned, has really made an impact on what we're doing. But we've also done collaborations with Rice, with UT Austin, with University of North Texas, with the University of Houston. There's a huge amount of talent out there, and so if I could get, I love the point that we need collaboration. We need feedback for all of you quantum computing companies out there. If you have, there's a spot where you could use better precision in the different things. Right now, I'm working on mainly 2D precision, but we can go 3D. If you have parts where you want to improve your optics, you want to improve your lasers, you want to improve your whatever components go into making your quantum computing efforts, come tell me about it. I think we stand a reasonable chance of making significant improvements on the precision that you have. So I think that more collaboration we see within Texas. I think there can be a rising tide that lifts all boats, if you will, in the area. There's a huge amount of capability here that can be extremely relevant to quantum, and I think that's very important. The last thing I want to do is come back to workforce, and in particular, Girl Scouts. One very important company said that they would be willing to put a portion of the $25,000 that I want. I just need 4 other companies, maybe each one gives $5,000. And actually, a great suggestion showed up a little while ago to me that they don't have to be quantum companies. There'll be companies that would benefit from quantum. See me. I've been trying to raise this $25K for the Girl Scouts for a long time. This really could help out. You want a quantum literate workforce. Somebody said, what do I mean by workforce? A quantum literate workforce. You don't have to know all the math. You don't have to do a deep dive into error correction of quantum computers. But if you just know there's a fundamental probabilistic nature of, there's a certain ambiguity built into the universe, that just helps you understand why the weakness and the strength of quantum at the same time. So if you've got company coffers that can afford $5,000 to help out with the Texas workforce by teaching a bunch of Girl Scouts how to be quantum relevant, that would be greatly appreciated.
Thank you very much. Message received. By the way, do we have time for a few additional questions? How are you? 18 minutes. Excellent. So maybe a question for those of you who have smaller businesses here. So maybe yourself, John, Bill, Pops. Often states struggle when they create incentive programs to attract businesses because they're designed for larger businesses. And it's like, we're going to give you a tax break. How does it help me if I'm spending more than I'm making? I'm still at an early stage. Or we'll give you X dollars of training per employee. That's fine, but might not be enough. So I don't want to put, I'm realizing I'm kind of leading the witness here, but feel free to disagree. Do these incentives work for your companies? And if not, what would work better?
Let me say that incentives from the state, and I heard our Texas representative mention that by states putting in money, federal funds will follow.
Yep.
Okay, I was very happy to hear that. That's actually been my experience. I got a substantial amount of money a number of years ago for the Emerging Technology Fund of the state of Texas. That helped greatly. I agree that there's sort of an impedance mismatch, if you will, between money that goes to large companies versus money that goes to small companies. And the state would do well to think about how to better distribute money, especially tax breaks, like you say, for a company that's barely profitable. trying to do something like quantum computing don't help a hell of a lot. But I love what Tan Parker said yesterday. I really think that the Texas government is very serious about helping out specifically quantum companies. So, the more support we can get from the state, may think a little bit better about how to provide that support, but that's outrageously valuable.
Thank you.
So, thank you. I mean, and we are in a different, because we're a nonprofit. But one thing that I wanted to communicate is that in the Microelectronics Commons R&D that we are funded by through the Department of Defense, our program manager is very, very keen to make sure that we make the PDK that we are developing white box and open to researchers to use, right? And so one of the things that'll happen is once we have the PDK, we need to have an MPW program so that people can run and use the.
Perhaps you can
the
explain
design.
some of the acronyms.
Sorry. Okay, and I was talking with Will Oxford a short while ago. So PDK is a process design kit, right? I mean, it is what allows a designer in a fabless company somewhere to access, let's say, TSMC's or Global Foundries or Samsung's technology and get their circuit fabricated. There isn't one for 300 millimeter superconducting qubit fab right now. I think IQM is developing something at 200 millimeter, but a process design fit kit for quantum is a beast that is still developing. All of the analog aspects that need to be encoded into the PDK, we're learning how to do that, right? But we are taking the first steps towards that. So an MPW program is, once you got the PDK, a multi-project wafer where you don't need to pay the $300,000 or whatever to get chips out. You buy a little tile on the wafer so that you can get your designs in. This is widely used in the semiconductor industry all over the world. And part of the conversation I was having with Will Oxford was to say, I believe that the PDK methodology supercharged the electronics industry and made it the near $1 trillion industry that it is today. Imagine the same thing happening for superconducting quantum or other quantum technologies, right? If we're able to make a miniaturized photonic integrated circuit that allows, let's say, IonQ to dispense with the lasers and have a little chip that does the control. Or same thing for your microwave circuit-based control. So there is opportunity here that we can take advantage of, but it doesn't mean that, yes, once you get the technology developed, that it is going to come for free. One thing that New York State has done, which I think maybe Texas can do, is to make it possible for all of the startup companies that are coming out of universities to find a way to access technologies and services so that they can get their circuits across the valley of death, right, into commercialization that much faster. And as I was saying before, as the Texas A&M facility grows, there'll be an opportunity to do the same thing right here, right? But the same methodology would still need to exist for the state to help small and startup companies to see their ideas come to the point where a venture capitalist says, okay, here is the $100 million check that we're giving you to commercialize your technology.
So you're removing some of the big fixed costs that are an impediment for these smaller companies to innovate, and in doing so enable them to innovate to the point where they become attractive for private investment to come and continue kind of expanding their business.
I wish you put it so beautiful. Thank you. Yes, exactly.
I'll add that we actually don't get too much direct funding from the state of Texas. We are on the DRI program, but you're not going to find very many quantum contracts or opportunities on that. So what we do primarily is we team up, as mentioned, with larger organizations. Deloitte is one that we've been talking to recently because they actually have a quantum arm that's working on algorithms. So that's one way for us to try to take advantage of potential money that comes our way. Our primary company has been in existence for about 30 years. So we're way out of the 8A, which used to be another opportunity for us to try to get some of these government contracts more directly. The reason we team up with universities, academia, is because we do have an FCL, facility clearance. We do have a cage code. We do have past performance reports that have been satisfactory. So we have a way in, for example, to apply to an RFI from DARPA and AFRL, which we've done some white papers for. Not always successful. We have had some positive responses, but of course, for example, AFRL is more interested in networking and sensing about 2 or 3 years ago when we submitted some RFIs, but we keep trying. So that's the one thing about our company is we've been bootstrapped, which means we never have received any type of outside funding. We basically have worked with primes, but we're go-getters. I mean, we're always trying to find new opportunities. We really can appreciate what's going on in the quantum world, and I can attest to the fact that we're always trying to keep ourselves abreast of what's going on, and if there's any opportunity that the state might be able to provide, we would be more than willing to accept and work towards that. We're not looking for a handout. We're basically looking for a hand up, as we like to say, and it's important for us to stay involved.
Yeah, thank you. I mean, the message transpires through the way you communicate it, and good luck in being able to continue and expand. Perhaps to our larger player friends here on the table, somebody mentioned startups. What do you do, whether it's at HPE or at AWS, to help startups benefit from the knowledge that you have and from the investment that you have?
I can maybe start. So we have a pretty large partners organization at AWS in quantum computing that works very closely with other quantum companies, many of whom are startups. This includes as well larger companies like Deloitte and Accenture and the big players as well, but the Partners Org works very closely with them. There's something called the Amazon Partner Network, which is a way for other companies to sign up and become part of a larger effort. This gives them access to I guess some joint go-to-market material and things like that, but as well in professional services capacity, it's a way for us to co-deliver on projects with other customers. So this sometimes means that when we have something in mind or a customer wants to work with us on some particular project and we think, actually, I know of this company who has a very good approach or has something that we could leverage, we're able to then bring them in and they'll be subcontractors on a project with us. So that way we partner very closely with them in that regard. And it goes both ways. This is sometimes they'll have a customer coming in who wants some support, and then we have experts in our team who are domain experts in many different things because we've got some fantastic folks on the team, and that lets us work jointly on their projects in kind of the same capacity. I think the nice benefit though is largely in when we are able to work together, we have a nice way to amplify that work. So smaller companies, when we do some joint work, even if we're less involved, but it's sort of part of the process, this lets us really showcase the work at some of our large conferences where, for example, AWS reInvent happens every year in Las Vegas with on the order of 50 to 100,000 people that just sort of flood to the strip, and we can put that on stage. We have blog channels and all kinds of things where we can really amplify that work, and we've seen this work pretty successfully, and hoping to do some more.
Thank you. Xin?
Yeah, so I think for HPE, we see some commonality with Amazon. We have all kinds of collaboration programs specifically. That's as far as I know, because we are more towards the technical parts. But through this HPC QC projects, we actually have a lot of partnerships with small startup in both software and also hardware, just like the DARPA Phase A we have just accomplished. It's actually a lot of, because we cannot do everything. We have a specific Pathfinder project and a department that within HPE that's specifically going out and trying to help us to partnership with the small startups, both software and hardwares. And then from the joint adventure, that's one way that we kind of collaboratively submit a proposal by working together, just like the DARPA Phase A. We are leading the consortium, but a lot of different aspects, like the qubit manufacturer is specifically by one startup company, and then some of the FTQC software is by other company. And then we test out and then trying to see, because we are the system integrator in that sense, we get a sense of how they work and how well they work out together with us through all those collaborative proposal submission and joint adventure. And also the Pathfinder will also help us to advertise in blog channels. We have a lot of blog posts in the last 2 years on the quantum side, HPC quantum, and also we have Discover in June every year that HPE has a Discover event. That's really big, so a lot of startups will come to the Discover event and trying to talk with different aspects because it covers many, many different aspects. And then we also have down the road, there are acquisitions as well that will happen if we see something that's really very well aligned. Then that's definitely, you see a lot of acquisition announcement in different areas that kind of acquire some of the small startups. So those are kind of the working mode we are.
No, thank you for sharing those. I wasn't aware. I was aware of the AWS program to onboard startups and give them access to services. So it's very helpful to hear both initiatives that you have. And if students or startups are sitting with us here, please feel free to reach out to our friends on the panel.
Yeah, if I may add, there was a glaring hole in what I said. I forgot to mention, of course, that we have our AWS service for accessing quantum hardware. And so there are hardware startups as well who can and should be, or would, if they'd like to be, putting that hardware online through the cloud. So I should have mentioned this as well. But indeed, our list of providers will continue to change. And so as new startups appear with great chips, please get in touch.
Thank you very much. Any questions from the audience before we wrap up? I see someone standing there, please.
Yes. So academia and industry often work on different timescales, sometimes with different goals. And you can have, on the one hand, academia generating innovative ideas that may get adopted by industry. And on the other hand, you may have industry that has pressing needs that need to be solved and maybe looking to academia to solve them. If we look at these two, what do you think is the more important strategy to optimize innovation and adoption? Is it a push or a pull? And please don't just say both.
If you can just state your name.
Oh, sorry. I'm Brian LaCour. I'm from the University of Texas at Austin.
At Austin. And are you directing your question to the entire panel or someone in particular?
I will address that to whoever wishes to answer.
Okay, thank you, Brian.
Presumably, so long as they don't say both.
Yeah, that's the trick.
Okay, angels fear to tread, fools rush in. I do believe the answer is both because you cannot have one over the other. But there are clearly ways in which that transfer in both directions can be improved than it is currently being done, right? I mean, and in my role, I was with Semitech, after I left IBM Research and moved up to Albany, and now at NY Creates. There are many conversations that I have with faculty members that have new ideas, new startup companies, that they say, oh, by the way, we made a hole through the entire wafer. Can you do it at 300 millimeter wafer scale, right? And so then invariably the answer is, that's a great idea. How about if we move it slightly differently and do it in this way so that your success is much more assured as you scale it up to high volume manufacturing. So I think that conversation, you've got me on my soapbox, because it is important that that conversation happen as early as possible so that the faculty member and the students don't waste their time, or at least use it much more of their time to focus their experiments on what might be useful for scalability, in addition to getting the nature and the science papers that are important. And for the reverse side, maybe I'll keep my mouth shut and let the experts talk.
Yeah, let me say push as opposed to pull. Especially when you're trying to do something that is so very different from what the industry's used to in terms of doing micro and nano fabrication. But you can so I have been outrageously successful finding outrageously talented professors that have capabilities that are fantastic, but they're not applying it to what I want them to apply it to. I have to come to them and say, look, we can go after, the carrot, of course, is a fat DARPA program that we're the prime and they're the sub, and that's worked out marvelously well. But we're trying to do something that's not in the general path of even academics. So in our case, it's a push for sure.
Yeah, I'll just add, for me, since we mainly deal on the software side, I'm actually looking at posters all the time. I'm talking to people in academia who are working on different projects, and if it's something that aligns with what we're sort of looking at, based on what our customers, that is on the defense side, are looking at, then we try to at least say, let's reach out to this particular group and find out what it is that they're doing and see if they have an interest in, creating a white paper or responding to an RFI where we might be able to join together. And then I think also, Xin mentioned here, there's also a need for her to understand what academia is looking to produce or provide, or what kind of resources they need. And I think you mentioned that you were also looking for algorithms, et cetera, that people are working on in academia.
Go ahead.
Yeah, sure. So I think in HPE we have a lot of areas. We have very close collaboration with academia, and there are near-term research, there are long-term research, and actually within HPE, it's kind of a different parts of the company sponsor for long-term research. So we have labs very specific looking at long-term research that might not be immediate applicable for today's technology, but we want to follow that. And maybe at some point there are some breakthrough. We don't want to be left out. And we also have more BU-oriented kind of a structure that's looking towards application, more quote-unquote applicable near-term research. So like software and hardware, we can directly integrate maybe next day through students or researcher collaboration into our system, and we can quickly roll out to the customers, different kinds of customers, because we have customers of a wide range. We serve customers that are more industry-oriented, like oil and gas, and then maybe some of automobile, like Toyotas, all those kind of customers. They want immediate application. They want immediate solvers, all those things, and even national labs. Sometimes for very specific, they just want a very quick turnaround. And we also have long-term customers that are more government-oriented, like DARPA, and then also other kind of a DoD customers that are more towards long-term research and want to see each mini stamps that's realizable along the way. So we definitely have a variety of portfolio and different department and functionalities within the company that are following different kinds of near-term and long-term research, at the same time serving different clients. That's how we operate.
So clearly it's an interesting question because you've solicited responses from every panelist. I think from my own experience, I started as an academic and then I switched over about 6 years ago. And I think it's, I'm wrestling with your constraint to not say both because it's like a frustrated system. On the one hand, these are two different approaches that solve different problems and have different sort of mandates. But you don't want to do both. From Amazon's perspective, one way they got around this was to put our research institute that is building hardware and doing theory on the campus at Caltech. So it is, in some sense, both, and you get the best of both worlds. And the point is that there are shorter-term, more immediate challenges that need to be solved for the mandate of the company. But at the same time, this technology is still emerging, it's still sort of pre-competitive, and we need to think as a community about it. And so we also need the ideas from the academics that are maybe slightly longer term, for example. From what I've seen, we've got this. We're very fortunate in that research that is happening within industry is still very much an academic kind of job compared to other industries. So quantum is fortunate in that way.
Thank you.
Yeah.
Thank you much. We have 2 more questions and 5 minutes, so 2.5 minutes per answer. Nicole, you go next.
I believe he's next.
Okay.
Thank you so much. Hi, my name is Shahryar Jaffer. I am a PhD student at UT Dallas. I recently attended the IEEE Quantum Summit at Albuquerque, New Mexico, but I would like to say that this is by far better than that. Number one, because the Wi-Fi works better here. Number two, since we all are Texans, so I can use like howdy and y'all without being judged. So my question is that we are talking about the quantum and industry and applications. So what would be in your prospect the first actual bottleneck which the classical computers have, which the quantum computer will break into for as far as the industrial application is concerned? Like we talk about different applications, but as per the panel's perspective, what would be the first one of that? And the second part of my question is that right now, what should industries do before the big boom of quantum is here? Like, how should they step in? We have the companies which are working in the quantum, but I'm talking about the industries which are working in like the outside the practical domain industries, factories, oil rigs, those kind of applications. What should they look up to right now, since we are getting into that quantum era?
Just real quick, we're working on ultra-high precision and ultra-high resolution fabrication technology, and the applications for that are extremely important in quantum, but much wider than that. There's a lot of other things can be done.
Yeah, when working with some companies who've talked to us about, quantum-based solutions, PQC seems to come up, a lot of the hosting and energy companies that we've talked about, but they're not ready to buy. We've presented to them, we've given them some information, but I think they're just wanting to know about it. A lot of these organizations, if they're not that large or if they're not as familiar with quantum, they're probably not going to get a team or even a person within their organization. They're going to look towards consultants to satisfy some of their curiosity.
I can hazard a guess, right? This will be my own personal opinion and not that of my employer or whatever. But I think when trying to guess what's going to be the first application, I would suspect it'll be some sort of Hamiltonian simulation problem where there's a material or a process that is happening efficiently in nature, but is hard for a classical computer just because of the dimension of the problem. Less likely to be in the near term things that require us to load large amounts of data into a quantum computer because the primitives to handle that are inefficient. And then iterated optimization problems. Optimization's a good candidate, but in the shorter term, many of them happen to be iterative, and then you just need many extra rounds. So then this is the natural question, right? Why, when, and why should a company or an industry get started, depending on their application? And I think the right answer is that not everybody needs to be panicking that quantum computing is coming right now. Some use cases are just not, some people are solving problems that classical computers are just amazing at, and not every problem is a nail that needs to be hit with the quantum hammer. But there are those that are repeatedly hearing that their applications and use cases are the things that quantum computing might disrupt eventually. So how to get started is just keeping in mind that it takes time to build up the understanding and the knowledge to figure out which problems will be solved and how to frame the problem such that it is amenable to a quantum computer. So I think just remaining, even if they're in an industry that's not the first to be disrupted, just remaining sort of in contact and maybe having some folks who are keeping abreast is helpful at the very least.
Thank you much. I'll add that in our experience, take 24 months once you know a problem to develop and refine your algorithm. So this is why starting ahead of when you're going to need it is a good idea. Nicole?
So I'm Nicole Barberis, Senior Director at IonQ, and my question is for HPE and AWS. So in your large language model workloads, are you seeing clients asking to insert a quantum layer, or do you expect it's really just going to remain big data, always classical?
That's actually a very interesting question and a very good question. We actually got asked about that from some of the clients, whether the advantage of quantum computing in the machine learning, the AI era. So I may not directly answer your no with our conclusion, because we are also actively exploring whether the real application, the quantum code-encoded advantage, is in the classical data or actually more on the quantum data itself. So we have research that are actively exploring the areas like quantum phase identifications that are specifically for quantum data. And the current consensus is that for quantum data, for quantum machine learning algorithm like QCNN and maybe some of the reinforcement learning that dive into some of the quantum mechanisms behind it, are really showing the advantage in terms of the quantum data. But in terms of the classical data, we don't have a clear conclusion yet.
Thank you.
Yeah, I do get this question when I talk to customers that are interested in AI and they think quantum is a hammer for every nail. I do get it quite often. I think the jury is still out a little bit. This is very much an active area of research, and to me it feels a bit premature to sort of to say that we're going to be putting anything into any layers that are running on a quantum device. I think that would be a cool problem, and we still need to do the groundwork to make sure that it's something that will actually benefit the workflow. There are speed ups, and there are no devils in the details.
So they're asking for it, but it's still experimental.
I mean, so Amazon's LLMs and things like that. It's a very large it's a very large part of the organization, and I'm sure you can imagine that some quantum people over here asking them to do some stuff may not actually work super well. Customers do come in asking about a quantum enabled or a quantum enhanced ML AI workflow, or using quantum machine learning to really sort of get a competitive edge today over their competitors who are using a chatbot or something. The reality is that quantum devices are not quite there, and this would be very much a research effort. So oftentimes this is sort of a conversation starter, but then one of the things that we like to do at Amazon is to be a voice of reason and to dispel hype. And so in that case, when we oftentimes customers have asked us this because they've heard that quantum computing is just going to, it's here and it's already going to speed up machine learning and everything today with the devices we currently have available at scale, and we just tell them that's not the case. So that sort of shifts the focus into something a bit more, it sets the ground layer, the bedrock on which we can have the conversation and figure out where we need to get for the problem they're trying to solve.
Yeah, I'll add
And
if you don't.
we're getting the same questions too, so I was just curious about
Yeah, we do.
if our experience was the same as what you're seeing.
I'm sure it is.
Yeah.
Yeah, I just wanted to add to that. So that is a big issue, and I know that current machine learning models and algorithms are not directly not direct analogies to what we know in the AI. So my background is also data science, and we're not actually we're using something called QCNN, or which should be the same thing as CNN, but it's not, of course. If you understand the pooling process, we're not actually using a kernel to scan across. We're basically just dropping qubits. So there's no direct analogy, at least for the most part, in every single step. So the idea here is people are moving towards other quantum-inspired solutions, understanding that we're trying to apply what we know on the standard machine learning AI side over to quantum, but that may not be the best way to go. That's just what we know right now. The idea may be that there may be new algorithms or new ways to do things that are more applicable to the quantum side, especially on the quantum data side. In other words, can we just use photosensors or things that are giving us information in wavelength form that can be integrated directly into a quantum algorithm? That's another way to go, but these are some things that I think we're still at this level trying to discover whether QCNNs are going to be, and there's plenty of papers that talk about, and that may not be the best way to go. Reinforcement learning or even some RAG usage, is that really going to be applicable to what we're trying to do on the quantum side? Maybe not, but that's just something to keep in mind.
Well, thank you very much, first to the panelists for joining us, to the audience. There is one more question. Can we take one? Okay, we're going to go fast, please.
Okay, thank you very much. I guess the panel maybe kind of answered my question already partially. By the way, my name is Yong Chen. I'm from Texas Tech. So my research area is really in the HPC. So I'm really interested in the HPC and quantum integration. So I guess my question may be more specific to our HPE and Amazon panelists. So I was really curious, are you guys working on some specific kind of follow-up question to the previous audience, like specific questions, you combine HPC and quantum computing to solve? You know, especially nowadays we are moving towards the AGI, artificial general intelligence. You know, are there any problems that, you know, maybe vision part can be solved by GPUs? Are there other problems, maybe scheduling, planning, traveling, salesman problems? You know, are you working on actually a specific problem, right, using the HPC and the quantum to solve? And also, while you are working on that, do you see any research challenges that potentially academia university can collaborate?
Yeah, so there are some work that came out. So yeah, Amazon had some work recently, along with several other major customers too, or companies to integrate GPUs, so alongside with NVIDIA, to speed up like the classical aspects of a larger problem. And then there's a quantum nugget that is run, and you find very large speed ups, but largely because also now there's a lot of thought going to the HPC component of this in the pre-processing. And I think this is a nice kind of result. Our team has also some work where we had a hybrid problem. So for example, if you wanted to solve the maximum independent set problem, there are heuristic classical algorithms that will do this, where at some point you do everything sort of ideally and exactly, and then it gets stuck and you're not sure what to do. And so one thing you can do is appeal to a heuristic to say, what do I do next? And for example, you could use the Rydberg atom devices. We use QERA to solve a small kernel of that problem and then suggest what you should do next instead of a classical heuristic. But the nice benefit here is that you also get like an incumbent solution for the whole thing. And this, you can imagine when you want to solve a very large version of it, maybe you couple it together with high performance computing to do some of that classical work in these kinds of hybrid workflows. If you're asking about coupling a quantum device directly to HPC resources, there are good reasons to do this. For example, when you're doing error correction, you need to, depending on your hardware, you might need to be very quickly decoding and then doing the fix-up. But other architectures have very long-lived stable qubits and don't necessarily need like on-chip immediate HPC to give you the result. You could just use a classical thing next to it, and its timescales are fine. So for sure, there is definitely research depending on the hardware and the use case into putting these together, and I think it's a pretty fruitful way to go.
Thank you.
Any additional answers? If not, thank you very much, Pops, Grant, Xin, Bill, and John for joining us. Thanks for the audience for all the questions.